All right, my friends, we are now about to dive into the wonderful world of routing, layer 3 addressing. A word here before we get started with this section. I'm not really assuming any prior knowledge of routing. And what we're going to do in this particular section is take an illustrated look at several fundamental situations of how routers will handle packets, basically when they know where to send them, and perhaps some scenarios where they're not exactly sure. And what I want to do first, what we're going to do, because it's a much more effective way for you to learn the material, is we're going to see it in illustrated form on the board first. And then as we go to the static routing sections, the OSPF sections, and all the other routing, we're going to be doing that on the live equipment. But this is a great section for those of you who are experienced networkers, just to make sure you're solid with the fundamentals. Those of you who are new to it, you're really going to love this section because I've got several different scenarios for you to see up on the board that will show you exactly how routing works. And when you have the fundamentals down, then you can start building the more advanced skills. Now, for one host to send data to another host, we know now that we need two addresses for the destination. The sending host has to have two addresses. We know it's two because we've been spending all our time up to this point talking about the less obvious address, the one we don't pay as much attention to sometimes in production networks, that being the MAC address, and the obvious one is the IP address. Now in this section, we're going to concentrate on Internet Protocol addressing. And these addresses are often called network addresses or layer 3 addresses, since that's the OSI layer at which these addresses are used. Now, a quick word here. The IP address format that you are likely familiar with, an address such as 192.168.1.1, that's an IP version 4 address. This address type is the focus not only of this section, but of every other section in this course except one, and that, of course, is the IP version 6 section. Version 6 is out there. We need to learn it. I'm going to get you ready for the CCENT here in this course with it and get you set for fundamentals. And I'm going to actually have a separate IP version 6 course that I hope you'll check out this fall, fall 2013, that is, on Udemy. Because if you are intimidated by version 6, I'm just going to tell you right here before we start with version 4, you're not alone. A lot of people are. But I'm going to take care of that. We're going to get you solid with the fundamentals in this course. You're going to see how much more effective version 6 can be over version 4. But then we're going to leave it there, and then you'll have an opportunity to build on that skill set in the future. But the vast majority of this course is going to be about IP version 4. Now, the routing process and IP both operate at the network layer of the OSI model. And we're not just interested when it comes to routing. We don't just want to get data from point A to point B. We want to get it there in the most effective / efficient / fastest way possible, because we want that redundancy, right? We want redundancy in our switching network at layer 2. We want redundancy at layer 3 because we never want that single point of failure. But when we have multiple paths, as we're going to have later, then we need to have a way to decide, okay, of these three paths between A and B, what is the most efficient course? What is the most efficient course of action for us to take to get the packets where they need to go? Now in this section, first we're going to take a look at IP addressing in general. Then we're going to look at some illustrated scenarios about how routers make a decision to how to get data from source to destination. Now the routing examples in this section are going to be simple. They're going to be very straightforward, nothing tricky, but boy, do they illustrate fundamentals that you've got to have down in order to use dynamic routing protocols, understand how they work, and go on to more complex examples. We are going to do some binary conversions here at the very beginning. If you have not taken that part of the course yet, no problem at all. This is a great introduction. We're not going to be getting into a lot of subnetting here, but I want you to see where the subnet masks come from. There's also some memorization here. You're going to need to memorize some of these values, but the great thing is, as you work with them in your subnetting practice, it all becomes second nature. So you might want to pause the video and grab something to write with. Now let's talk about IP addressing and a little bit of an intro to binary conversions. Now, most of you are likely familiar with IP addresses because every PC on a network has to have one. Every host device has to have one, and that's the term for an overall network device, is host. And I'm going to use that term as often as possible just to get you used to it. But they've all got to have an address. And for example, we looked at ipconfig on a PC earlier, but I've got it on the board here for you as well. Just a couple of basic values, because this is where troubleshooting can also start. Of course, after we do the physical layer, make sure everything's turned on, that kind of thing. When you run ipconfig, you're going to see your device's IP address, your PC's IP address, that is. You'll see a subnet mask and something called a default gateway. Now, we're going to discuss the default gateway later in this particular section. Right now, I want us to concentrate on that IP address of 192.168.1.100 and that subnet mask of 255.255.255.0. We're going to compare the IP address and the subnet mask, and that allows us to see what network or subnet that particular host belongs to. And to do so, we convert both the IP address and the subnet mask to binary strings. Now, if you have not done this before and you're sitting there, I can only imagine, I don't have to imagine actually, when I've taught this course live, everybody's really anxious on Monday morning. You know the deal with the kind of antiquated 5-day, work all day boot camps. And, people, you're always anxious on Monday morning, that kind of thing. And, it gets you get a little tired during the week, that kind of thing. But boy, when it got to binary, I practically had to drag people in. I'd sit there and I'd see people, and I imagine this is what it looks like when you're sitting in the electric chair. Just waiting for the voltage, You see people just sitting up and they're just, their fingernails are going into the wood because they're nervous about it. It's nothing to be nervous about. I'm going to have you working so smoothly with binary conversions that you will be amazed. And I've been doing it for almost 10 years, and I've gotten tens of thousands of emails, people saying, I didn't know it could be this easy. And that's exactly how it's going to work for you. It is not bad at all. Like I said, we're going to work with binary and subnetting in another part of the course, hardcore. That's going to be all we do in that section. But there's a reason I'm showing you how to do this now when it comes to that address and mask. The first thing we're going to do is convert that IP address, 192.168.1.100, to a binary string. And the format that we're used to seeing IP addresses take, like that particular address, that's what we call a dotted decimal address. The values are in decimal, and there are dots separating the decimals. See what I did there? Actually, I didn't do it. I didn't come up with those. But that's what we have to do. Each one of these numbers in the address, 192, 168, 1, and 100, we're going to consider them separately, and they're decimal representations of a binary string. So we really don't think about that when we're counting out change or just, counting on our finger, 1, 2, 3, 4, 5, 6. We're not thinking, oh, this is decimal counting and this is how I do it. You just do it because you're used to it. That's the same way binary is going to get for you. Because remember, it all comes down to ones and zeros. Now we're going to convert the decimal 192 to binary first. And if you're familiar with binary conversions, you've probably already done it in your head. If not, fantastic, because you soon will be. All you have to do is use the following series of numbers and write the decimal that requires conversion on the left side. This is exactly the way I do it, because when people used to get so nervous about binary math, I'd say, I'm going to give you the Bryant Advantage binary math pre-qualification exam. And then their fingernails are really digging into the wood. And I'd say, hey, if you can double the number 1 7 times and add and subtract, you can answer any question. You just need the practice, and you don't need tricks, and you don't need magic. All you have to do now is work from left to right and ask yourself one question. Can I subtract this number from the current remainder? This is the kind of thing that when you read it or you hear someone talking about it, it sounds complex. But as you can see on the board, it's really not, because we're going to walk through this example, and you'll see how easy it is. Looking at that chart, ask yourself, can I subtract 128 from 192? Sure I can. That means you just put a 1 under 128. Now if you subtract 128 from 192, what is the remainder? The remainder is 64. So now we ask ourselves, can I subtract 64 from 64? Sure you can. Let's put a 1 under 64. And see, you're almost already done with your first binary conversion, because now you have 0. You subtract 64 from 64, you got 0. You're practically done. Once you reach 0, just put a 0 under every other remaining value, and you have your binary string. And that's it. The resulting binary string for the decimal 192 is 11 followed by 6 zeros. That's it. That's all there is to it. And I'm telling you, I know I talk about the fundamentals a lot now, how important they are. I'm sure you'll agree with me, this is not difficult. The more practice you get with it, and then you go to the more complex questions, you're going to nail the exam. You're going to do really, really well. Now, let's go ahead and head for the next board. Let's go ahead. I've already converted 192, 168, 100 here on the board. And if you haven't done that before, if it's your first time, go ahead and stop the video and convert it without looking at what I did. And you'll see why I did this. Because right under that, I simply wrote out the network mask, or the subnet mask in binary. And 255, you know what that's going to be. That's going to be a 1 for every single value in that particular block. So 255, 255, 255, 0, when you break it down into binary, is going to look like this. It's going to be 24 ones in a row and then 8 zeros. The subnet mask indicates where the network bits and the host bits are, and this is going to be a very important thing for you to know, because the network bits of the IP address are indicated by a 1 in the subnet mask, and the host bits are where the subnet mask has a 0. So right now, this address has 24 network bits, and the network portion of the address is 192.168.1 in decimal. See, when we just apply that, we're only looking at the first 3 blocks. Now, why did I show you this now instead of in the big binary and subnetting section? Well, any IP addresses that have the exact same network portion of the address, they're considered to be on the same subnet, or they are on the same subnet. If the network is configured correctly, hosts on the same subnet should be found on one side of the router as shown here. This is what we call a best practice. Cisco has a term called best practice where they have certain rules and they just say, this is for best results the way you should do such and such. This is best practice right here. You want to have all your hosts in one subnet on one side of the router. And as we go through this section, you'll really see why. Now, assuming a subnet mask of 255, 255, 255, 0 for all the hosts, we have 2 separate subnets here. We have 192.168.1x and 192.168.4x. Hosts on the same subnet should be on the same side of the router, and you can see here that they are. All of our hosts in 192.168.1 are on one side of the router, 192.168.4 on the other side of the router. Now, what you don't want is something like this. And you'll notice we've got hosts on 192.168.10, that network. We've got one here on the left, we've got one here on the left, and we've got one here on the right. And for the other subnet, 192.168.4, we've got one on the left side of the router and 2 on the right side. Well, this could lead to a big problem because hosts in the same subnet are separated by a router. And we're gonna revisit this later in this part of the course. We're not going to skip ahead here when we examine the routing process later in this section. But for now, it's a great idea to keep in mind that having hosts in the same subnet separated by a router is not a good idea. It's not best practice. When we start the next video, I'm going to introduce you to the IP address classes and definitely some important subnetting information here as well. So I will see you on the next vid.